Hello teachers, today we start a new chapter, chapter 13, where we're going to talk about area, the Pythagorean theorem, and volume, and that also includes measure. And today we're going to talk about linear measure in section 13-1. So at the end of this section, you should be able to understand and explain the English system of linear measures, the metric system of linear measures, conversion among measures, dimensional analysis, perimeter and circumference, and ratios of linear measures of similar figures. So let's start with the English system of measure. Here's some common measurements that you are familiar with, I know. A yard is 3 feet. You should commit these to memory because your students are going to need to. A foot is 12 inches, and a mile is 1,760 yards. You might not remember that one as well, but you really should commit that to memory. And also 5,280 feet. So the question comes up, if you have to convert, say, 32 inches to feet or 5,647 inches to yards or to feet, how do you do that? What's the best way to handle that? And I have some examples coming up for you soon, but I have some thoughts about how to help you remember this and how to help your students remember this. Now, the way that I've seen a lot of teachers teach this is when you go big to small. Now, watch me draw. I tried to find some good cartoon pictures to just insert here, but I couldn't find any, so I'm about to draw for you. Stick figures, because I'm a great drawer. Okay, so big to small. So what you can do, or what your students can do, so this is you, all right, stick figure, and when you go big, you can open your arms out wide to express big, all right? So big, and then you're going to small, so here's you again, or your students, and small, you cross your arms in front of you. Right? So your arms are open big, and then you go to small. What does that imply that you do? Well, you multiply, right? So you have the big X here, which implies multiplication. So big to small. So if your unit of measure is big, and then it's going to a smaller unit of measure, for example, miles to feet, or yards to inches, that's going from a big unit to a small unit, then you multiply. And that's very easy to remember. So arms open wide big to small, you just cross them in front of you, and that means multiply. Well, what about the other way? What if you're going from small to big? So let's just start out small. Okay, and you can have your arms in a multiply position if you want, or just small. Make yourself small, okay? And then to big, well, you know what I'm going to do. Arms way out, make a really big deal of it. Now, what does that tell you to do? Well, let's think about it this way. What it's really telling you to do is to divide. How does this mean divide? This is your big division bar, and your head is one dot, and you could say your body is the other dot. So small to big, you divide. You like my drawings? And then big to small, you multiply. And I'm a math teacher. I'm very comfortable with conversions. I've been doing conversions for years. And I had someone tell me this not very long ago, and it's amazing how well it sticks. Even someone who's very comfortable with conversions and can think quickly about when to multiply or when to divide, and I actually do it a different way with dimensional analysis, and I'm going to show you that too. It's easy also. But when you're dealing with students, I think you're going to love this big to small situation and small to big situation. They're going to remember this, okay? Now, I did find another way to think about it, and it's pretty cute. It's pretty cute. So, horse to fly, multiply, okay? So, what does that mean? A horse is big, right? A fly is small. Horse to fly is multiply. Fly to horse, divide, of course. Also very cute, but for some reason, the body movements, and even in your education courses, you're going to learn that if you can do stuff, get students to do things with their body, it is easier to remember. But again, this is super cute. This might be something you want to research and put on a bulletin board when you're discussing measurements. So here's our first example. We want to convert 5.25 miles to yards. Okay, so remember our trick. If we're going for miles, spread your arms out wide, right? Miles to yards. Miles is bigger than yards. So this is big to small, which means you need to multiply. So we have our 5.25 miles. I start there. And what I like to do is replace the miles with its conversion. So I have 5.25. We're going to multiply that by the yards to miles, right? So that's going to be multiplied times, remember what it is? You need to commit it to memory. So 1,760 yards. And so notice what I did. I replaced the word miles with its equivalent, 1,760 yards. And when I multiply that out, and again, how did I know to multiply? Because we're going from big, hold your arms out wide, to small, cross them over in front of your chest. That means multiply because you're making the multiplication symbol. I even used it in my problem. You know, I typically don't use the multiplication symbol. So 5.25 times 1,760. I cheated and used my calculator. That's 9,240. And then when you use this trick where you just replace your units, then your yards is right there for you. You don't even have to go back and search and go, okay, what units am I doing? There you go. Now I'm going to show you the textbook version of this, and I was kind of perplexed about why they went through this much trouble to do it, but I just want you to follow me because it is a way to get there, and maybe it's a memory thing. So here we go. So they convert 5.25 miles to yards, okay? So they write that 1 mile is 5,280 feet, and 1 foot is 1/3 of a yard. So notice they didn't use the fact that 1 mile, right off the bat, we use the fact that 1 mile is equal to 1,760 yards. And maybe it's likely because a lot of students and even a lot of adults don't have that one memorized. So if you don't know that one right off the bat, but you do know that 1 mile is 5,280 feet and 1 foot is 1/3 of a yard, then you could do it this way. Again, I still have a little bit of an issue about how it's handled, but you multiply the 5.25 times 5,280 feet. That is how we handled it, but we just used the yards, okay? Then they multiplied it by 1/3 of a yard, and that gives us the same answer we got, 9,240 yards, okay? But here's my issue with it, okay, other than you're doing two different conversions. So if we say 5.25 miles, and we're going to replace that with feet, right? And so we're going from miles, which is big, to feet, which is small. You cross over in front of you, so that would be 5.25 times 5,280 feet, okay? And that's going to give me 5.25 times 5,280, 27,720 feet. Okay, but now you're going from feet to yards, right? Feet are smaller than yards. So picture, make yourself, your arms small, feet, and then to yards is big. Remember when your arms are out real big and wide, that's the big division sign. Your head is the top of the division sign, and then some point on your body is the bottom of the division sign. So now I'm going to divide. So I take 20,720 and divide that by my conversion, right? I'm replacing feet. How many feet are in a yard? Well, there's 3 feet in 1 yard. So I'm going to divide by 3, okay? So 27,720 divided by 3 is going to give me the same answer, 9,240. But now we know that that is yards, right? Okay? So they are doing it a very, it's a nice way to handle it. Notice instead of dividing by 3, that's really the difference here. They multiplied by 1/3, And you can always do that. It reminds me of dimensional analysis, and we will get to that shortly. But again, if you're teaching this to students, especially young students, I think maybe the first way I did it is the best, but if they don't have the fact that 1,760 yards is in a mile, then you can do it how I have it down here in red. Of course, it is up to you. It is your classroom, but we want to make this as easy for you and your students to understand. Now I want to talk to you about my favorite way to do conversions is what's called dimensional analysis. Basically, you're multiplying by a fraction that's equivalent to 1. I love this trick because when you are dealing with chemistry or physics or even some volume measurements, have you ever dealt with pecks and bushels? I don't know which one's bigger than the other because it's just not something that I use very often. So my trick of going big to small and multiply or small to big and divide kind of gets lost in the process. And when you use dimensional analysis, you do not have to know which one's bigger than the other. You just substitute. So let me show you with the same problem here how you would use dimensional analysis and what it consists of, and then we'll practice. So start with 5.25 miles. Now, remember what we're trying to convert it to is yards, okay? So you start with what you know, and you're trying to get rid of the miles. So you go to a conversion that you know that's equal to 1, okay? So this fraction, y'all know, just for instance, 5 over 5 is equal to 1, right? Or you could say 2 to the second over 4 is also equal to 1. It doesn't have to be written the same way. As long as it's the same value on top and the bottom, that's equal to 1. And you're allowed to multiply any value by 1 because 1 is the multiplicative identity, right? It doesn't change the value of whatever number you have going on. So when we multiply 5.25 miles times 1, right? This is 5,280 feet over 1 mile. They're equivalent. So this is really just multiplying by the number 1. Now, things you need to look out for. Whatever you have here, units, needs to go on the bottom. So always, whatever you start with must go on the bottom. Now, eventually, what you're trying to get to needs to be on the top of a fraction. Notice the next fraction, which is also equivalent to 1. Okay, 1 yard over 3 feet. They're equivalent, right? So again, I'm just multiplying by another 1 right here. It's a glorified 1. I call it a unity fraction. Unity means 1, or unit means 1 in mathematics. So 1 yard over 3 feet. Now notice this again. Feet's on top. I get rid of it on the bottom down here. Those cancel. And what I end up with is yards in my answer. And we know 1 yard is 3 feet. So again, the next unity fraction is 1. And so you just multiply all this together. Notice there really is some division here because when you multiply fractions, you have 5.25 times 5,280 times 1. And in the denominator, you have 1 times 3. And that gives you, when you finally divide it out, 9,240 yards. Now, what if we did this like the first way I solved it, but using dimensional analysis? We know we have 5.25 miles. Okay, start with what you know. Make yourself a fraction. Miles needs to go on the bottom, for sure, because I need the miles to cancel. Then I look up a conversion. If there's a conversion, or I know there's a conversion between miles and what I'm trying to change it to, remember, yards is what I'm trying to change it to. Is there a conversion? Absolutely. We know that there's 1,760 yards in 1 mile. So I didn't have to use the 2 different conversions. And we already know when I multiply 5.25 times 1,760, I get 9,240 yards. You happen to notice maybe that I didn't need to know if I needed to multiply or divide. You end up multiplying if your value is in the numerator and if you have a 1 in the denominator, and you divide if you have a value under than 1 in the denominator. So in the first situation, we did both. Remember when we did it the red way, kind of a little different than the book did it? and we had to multiply, then we had to divide. But here you do it in fraction form and you don't have to think about it. You just work with the fractions. So let's work on this problem using dimensional analysis because it works really well for this problem. So if a cheetah is clocked at 60 miles per hour, what is its speed in feet per second? So you notice you're changing two things. You're changing miles to feet and hours to seconds. And you can think about both of those conversions. You're going from miles to feet, which is big to small, which means we're going to multiply. And then you're going from hours to seconds, which is actually big to small again, and you're going to multiply again. But now if you use dimensional analysis, don't worry. You don't have to worry about that. So here we go. Write down what you know. So you have 60. Now miles per hour, you know what that really means. That means it's miles in the numerator and hours in the denominator. And you could consider that 1 hour. It's really 60 miles per 1 hour. You don't have to put the 1 there. It's not required. Now, remember what we're trying to do. We're trying to change that to feet per second. Okay? So I'm trying to get rid of miles. I'm trying to change it to feet. Okay? Remember, if miles is on the top, to get rid of it, I have to put it on the bottom. Why? So they'll cancel. You have to have the units on top and bottom. You cancel units as well. Okay, so feet and miles. Now let's go ahead and do that part of it. Okay, so how many feet are in a mile? We know this, right? So it's 5,280 feet in 1 mile. I didn't really need the plural miles down there, but that we're not going to worry about that. Now check out what happens already. The miles cancel. Okay, and now I have 60 feet per hour, right? Because the feet's still there, the hour is still there. But now I'm supposed to get rid of the hour also. So watch this. I'm going to multiply by another unity fraction, a fraction that's just equal to 1. Now my hour is on the bottom. I want to get rid of it. So you know what I'm going to do? I'm going to put it on the top. That's how the hour is going to cancel. 1 in the denominator, 1 in the numerator. What am I trying to change it to? I'm trying to change it to per second. Per means it belongs in the denominator. So this is working out how we planned. Second is in the bottom. Now let's do our conversion. What's our conversion from hours to seconds? Well, you probably know this, right? There's 3,600 seconds in 1 hour. How did I get that? That's 60 times 60, right? There's 60 seconds in a minute and then 60 minutes in an hour. And we could have even done that separately. They may have done that separately when they do their result. We'll look at that in a minute. But I want to do it how it makes sense to you. So here we go. Let's cancel, right? This hour in the denominator cancels with that hour in the numerator. And turns out we have 60 times 5,280 times 1 in the numerator. So 60 times 5,280 times 1. And in the denominator, we have 1 times 3,600. Now the denominator, I can do that in my head, right? But the numerator, I'm going to use my calculator and do 60 times 5,280. Did you hear that noise? That was my watch telling me I had a message. Equals 316,800. That's my numerator. Now don't forget about your units, right? What's still remaining units-wise is we have feet per second. And that's what our answer is supposed to be in. So that's feet per second. And then let's do the division. So 316,800 divided by 3,600. And I get 88 feet per second. Now feet per second may mean more to you. Miles per hour usually means something to adults anyway because we drive and we can relate to miles per hour. Whereas feet per second, it's a neat way to think about it. So a cheetah can cover 88 feet. That's a good bit in just a single second. That's a lot. That's a lot. All right, so let's look at the textbook version of this. Remember, we don't have to do it the same way. You don't even have to show it the same way to your students. You just want to be able to understand it thoroughly so you can share this knowledge with your students. So you want to be able to be comfortable with it and show them different ways so they understand it. Okay, so we start with 60 miles per hour, right? They wrote 60 miles per hour, and then the first thing they did, there's our first unity fraction, is 5,280 feet in 1 mile. That's the first thing we did too. Why? Because the miles, notice that, they cancel out. Then they wrote 1 hour is 60 minutes. Why did they do that? Because notice the hour is down here in the denominator. To get rid of that hour, you have to put it in the numerator. And they just used a conversion that they know. They know that there's 1 hour is the same as 60 minutes. Now, we didn't do it that way. We went ahead and said 3,600 seconds is 1 hour. But it's okay to do it this way separately. And I told you they probably do that. Now, where are we? Okay, well, we've got minutes in the denominator here, but our answer is not supposed to be in minutes. It's supposed to be in seconds. Now, since minutes is in the denominator, it needs to go in the numerator over here so it'll cancel. And then you have 1 minute is equivalent to 60 seconds. Okay, now notice what we end up doing in the numerator. We multiply 60 times 5,280 times 1 times 1. And in the denominator, I'm going to highlight all those in green. You have 1 times 60 times 60. And that gives you 88. That's what we got also. And notice the units that are left. I'm going to highlight these in yellow so you really see it. The feet is still there, and the seconds are still there. Listen, dimensional analysis is great once you get the hang of it and you do some of these problems on your own, especially if you have to take chemistry or physics, because you have to just convert and convert and convert. And as long as your fraction, as long as this guy right here is equal to 1, they're the same value in the numerator and the denominator, and you use the rule that if you have a unit on top, then in the next step it needs to go on the bottom and it'll cancel. If you have a unit on the bottom and you want to get rid of it, then it needs to go on the top of the next fraction and then cancel. If you use that convention, you will get there without a lot of thinking. Okay, now we get to talk about the metric system. So the English system, or the standard system for distance measurement, you know, you do inches, feet, yards, miles. With the metric system, it's actually much easier to deal with because it's all base 10 conversions, but the United States just will not grab a hold of the metric system, but it is so much easier to work with. I remember in first grade, and this was many, many years ago, we were told in first grade that we were about to change to the metric system, and it never happened. And y'all, that was a bunch of years ago, and maybe it will one day because the rest of the world uses the metric system. All right, so we know that kilo, or the symbol K, means 1,000, okay? So anytime you have a kilo, say meter, kilometer, it's a meter times 1,000 or 1,000 meters. Hecto, we use the symbol H, means 100, so a hectometer is 100 meters. Deca, you don't see that often, abbreviated DA means 10, so a decameter would be 10 meters. Now notice the meter is not included. That's the basic unit right in the middle. And then you start getting smaller. Deci means 1/10. So, well, that is 1/10, right? It's not 0.1, right? We're lazy when we say that. That's 1/10. So a decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter. And a millimeter is 1,000th of a meter. Okay, now when you look at the meters, here you go. Basically, I just said all that because I used that example is meters. But the metric system, if we go back here, the base unit could be meters if you want to measure distance. It could be grams if you want to measure weight, or it could be liters if you would like to measure volume. And so, I mean, it's powerful. There's a lot there. And so in this section, we're just working with measuring distance. Okay. Now, they give us some benchmarks for metric units. So notice the 1 meter is represented as like an arm length to a shoulder. I tend to hold my arms out in front of me, and I don't stretch them all the way out. But, you know, just out there kind of relaxed a little bit. That makes me feel like it's a meter. 1 decimeter. Okay, now notice it's not the DAM, which would be 10 of these arm lengths here. The DAM, just the DM is the decimeter, is about the width of your hand. A centimeter is about a fingernail width, or the tip of your finger, and a millimeter is super tiny. Notice that it's just like that little part or the width of a paperclip, not a whole paperclip, just the wire. That's 1 millimeter. And I like this depiction because, again, we don't use the metric system all the time. A lot of people have a good feel for an inch and a foot and even a yard, but the metric system is just not as comfortable for us, but easier to use, really. Now notice I like this step version of converting metric units. I tend not to write it as a step version. You're going to see how I handle this in just a minute. But the biggest of all these is a kilo. So a kilometer is the largest compared to a hectometer or a decameter or just a meter. That's what goes in the middle as a base. A decimeter, a centimeter, or a millimeter. Now, what I tend to do, and forgive me, I don't know where I left off. I keep having to pause the video to answer phone calls, but back, I promise. So kilo's the biggest, hecto, deca, the base units. So it wouldn't matter if this is meters, grams, liters. This system still works. And then smaller than the base is a deci, a centi, and a milli. And what I tend to do, again, is I write these. Whenever I have to do a conversion problem, this is a way to handle it. If you don't use dimensional analysis, which is the fraction way of doing it, which I love, really is my favorite, especially teaching adults, but teaching children, I think you might like this method. I tend to just write kilo, hecto hecto. I do have to write DA for deca. And then you can write base here, or you can write meters. It could be whatever you need. And then D for deci, C for centi, and M for milli. So this is a memorizer. Now, how does it work? Okay, if you're trying to change, for instance, from 5 hectometers to millimeters, you count your jumps. Okay, so hecto, well, don't count where you are. It'd be 1, 2, 3, 4, 5 jumps to the right. That's a decimal move. It is so awesome. Or if I was changing from centimeters to kilometers or kilometers over here, don't count where you start. That would be 1, 2, 3, 4, 5 jumps of the decimal to the left. And it's so easy to do. And then you might be thinking, how am I going to get my students to memorize the K, H, DA, base, deci, centi, milli? Well, right here. Love it. King Henry died by drinking chocolate milk. I have also heard King Henry died Monday drinking chocolate milk. The Monday represented meters. But if you're using, again, other units of measure, whether it's weight or volume, the by is the base. So K is the kilo. Notice I have it over here for you still. H, Henry, is the hecto. D, died, is the deca. Now you got to know that's the DA. By is the base. Drinking deci. Chocolate centi. And milk milli. And that thing sticks too. King Henry died by drinking chocolate milk. It's so funny. And then you could just use your letters to list and then bounce around. And it's awesome. So let's do some of those problems. So we've got 3 problems here. I do want to show you, say, one of them by dimensional analysis, but let me show you the fun King Henry trick, okay? So the first thing you want to do is write. So remember, King Henry died by drinking chocolate milk, right? And remember that I like to underline that because that's your base unit right there. So I have 1.4 kilometers. So I'm starting right here at 1.4 kilometers and I'm trying to change to meters. That's your base unit. So I start in kilometers. Don't count 1 there. You don't count until you move. So that's 1, 2, 3 moves to the right. So we're going to take that 1.4 and move it 3 moves to the right. So notice that's 1, 2, 3. So I have to add 2 zeros. So that's 1,400 meters. Isn't that awesome? Okay. Now again, I'm going to flip pages on you. Notice I have it written at the top also. So again, just as a reminder, King Henry died by drinking chocolate milk. Okay? Now you do the next two. Pause it, you do the next two on your own, see how it goes, and we'll compare answers. All right, so we have 285 millimeters, right? So millimeters is here on the end. It's the smallest unit of measure. Now, I'm going to count and see how many steps I move. Oh, notice I'm moving to the left. You know, the decimal is sitting right here. I know you figured that out. The decimal is sitting right here at the end right now. So from millimeters, don't count where you are. So I'm moving to meters. That's 1, 2, 3 units to the left. So if I move 3 places to the left, that's going to be 0.285, which is really, remember, 285 thousandths of a meter. And then the next one, we clearly see where the decimal is. I'm going from kilometers or kilometers to centimeters. This is a long way. So don't count where you start. That's 1, 2, 3, 4, 5, 6. Notice you do count the base. One more time. Start at the kilometer. 1, 2, 3, 4, 5, 6 units to the right. So that's 0.03. If you want to, you can just put a whole bunch of zeros over here, right? And count. So 1, 2, 3, 4, 5, 6. So that you don't put the zeros before a number, right? So that's a 3 and 4 zeros, which is 30,000. Uh-oh, did I go I went too far, y'all. What? You didn't stop me. I was thinking to millimeters, and it's right there at centimeters. So that's not right. I bet you thought you did it wrong. No, you didn't. So let me, one more time. So kilo to centi, not milli. So 1, 2, 3, 4, 5 jumps to the right, which means I'm going to just back up 1. And turns out this is going to be 3,000, not 30,000 centimeters. Is that how you did it? Okay, now let's look at the book's version, you know, because we always do that. And this is how they did it. I just filled in the answer. Does that match ours? It does. It does. You don't have to go back and rewind it and check. But maybe hopefully you looked at your notes and went, yep, that's it. So super easy, right? Now, real fast, I want to show you this with dimensional analysis. Then I'm going to shut this video down and come back for part 2 to finish it up because I've passed my 30-minute mark. So if we use dimensional analysis on this instead, let's do the first one. So I'm going to say 1.4 kilometers. Okay. Now, what I'm trying to do is get rid of kilometers, so I know it goes on the bottom. Remember, that's the trick for dimensional analysis. Now, meters needs to go on top or whatever I'm changing it to. Now, sometimes you want to change to the base, and then, like, so if this was like kilometers to centimeters, you might want to change to the base and then do the conversion from the base to the centimeters, but this went to just basic meters. Now, we know the definition of kilometers. There's 1,000 meters and 1 kilometer. And then you just multiply 1.4 times 1,000, which gives us 1,400 meters. And I would do it like this all the time. But again, when you're working with students, dimensional analysis doesn't go over so well unless you're working with older students. But when you first introduce this to young children, then I think you're going to like the King Henry story, right? It's great. It's great. It's like big to small, small to big, and King Henry. All right, so I'm going to let you go for this video. Come right on back for part 2, and we'll finish up this section. Hope you have a great day.